Hello, I'm Janet Young, and I'll be discussing three problems from the University Physics, Chapter 10, Dynamics of Rotational Motion. Problem 10.16. A 12 kg box resting on a horizontal, frictionless surface is attached to a 5 kg weight by a thin, light wire that passes over a frictionless pulley. The pulley has the shape of a uniform solid disk of mass 2.1 kilograms and diameter of 0.56 meter. After the system is released, find the tension in the wire on both sides of the pulley. You're given mass 1 of 12 kg, mass 2, 5 kg, mass of the pulley, 2.1 kg, diameter of 0.56 meters. Divided by 2, you'll get its radius, 0.28. Your vertical tension would be T1 is equals to M1G minus M1A. Your horizontal tension would be T2 equals to M2A. Our moment of inertia for a solid disk is equals to 1/2 mr squared. Your moment of inertia for rotational motion is I alpha equals to T1 minus T2 times R. Your linear acceleration is equals to angular acceleration times radius. Plug in your given values, and by using some basic algebra on the first equation, T1 equals to M1G minus M1A, to substitute the formula for A, and you'll get the first tension, which is 39.42 newtons. And now, you can get T2 by just substituting the acceleration using the first equation. And then you'll have 32.58 newtons of T2. B. Acceleration of the box. So you're given mass 2 and T2, and you're looking for its acceleration. T2 equals to M2A, and you'll get acceleration of 6.52 meters per second squared. C. The horizontal and vertical components of the force that the axle exerts on the pulley. Observing the free body diagram, we can see that the tension are exerted on the pulley also, and the total vertical force has the magnitude of T1 is equals to 39.42 newtons, pointing downwards, while the total horizontal component is T2 equals to 32.58 newtons, pointing to the left. Problem 10.18. We can roughly model a gymnastic tumbler as a uniform solid cylinder of mass 67 kg and diameter of 1.2 meters. If this tumbler rolls forward at 0.6 revolution per second, how much total kinetic energy does he have? You're given the mass of 67 kg, diameter of 1.2 meter, divided by 2, you'll get its radius of 0.6 meters. Your angular velocity of 0.6 revolution per second, you have to convert it into radians per second by just multiplying it by 2 pi, and you'll get 0.77 radians per second. We're looking for its total kinetic energy. The total kinetic energy would be linear kinetic energy plus rotational kinetic energy. Our formula for linear kinetic energy would be 1/2 mv squared, and your kinetic energy for your rotational kinetic energy would be 1/2 I omega squared. Your moment of inertia for a solid disk is equal to 1/2 mr squared. Substitute its values and you'll get its inertia. And you can now solve for its rotational kinetic energy, which is 85.7 joules. Your linear velocity would be radius times linear times angular velocity, and you'll get 2.262 meters per second. And now, you can get its linear kinetic energy, which is 171.41 joules. Just add the two kinetic energy and you'll get its total kinetic energy of 257.11 joules. B. What percentage of his total kinetic energy is rotational? So you're given rotation kinetic energy of 85.7 joules, total kinetic energy of 257.11 joules. To get its percentage, you have to divide rotational kinetic energy over total kinetic energy times 100%, and you'll get 33.33%. Problem 10.30. An engine delivers 177 horsepower to an aircraft propeller at 2,500 revolutions per minute. What constant torque does the aircraft engine provide? B. How much work does the engine do in one revolution of the propeller? You're given a power of 177 horsepower. You have to convert it into watts by multiplying it by 745.5 watts over 1 horsepower, and you'll get 1.32 times 10 to the 5th watts. Your angular velocity would be 2,500 revolutions per minute. You'll have to convert it into radians per second by just multiplying it by 2 pi over 60 seconds, and you'll get 261.8 radians per second. The formula for power is equals to torque times angular velocity, and you'll get the torque of 504.16 joules per radians. Our formula for work is T times the angle. Since you're looking for 1 revolution, your angle will be 2 pi, and your work would be 3.17 times 10 to the 3rd joule. That's it. Thank you.